Good morning, guys. Today we have to see about the engineering materials and metallurgy, unit number 1. Unit number 1 consists of constitutions of alloys and phase diagram. The subtopics are constitution of alloys, solids solutions, substitutional and industrial, phase diagram, isomorphous, eclectoid, perictic and perictoid reactions, iron carbon equilibrium diagram, classification of steels and cast irons, microstructures and properties. Introduction about these topics. The matter is usually found to exist in solids and fluids. All we know, all these materials consist of atoms and molecules. Solids are brittle, some are ductile, some are malleable, some are strong, some are weak, some are good conductors of heat and electricity, some are magnetic, some are non-magnetic, and so on. The reason of these different properties of solids are due to their structures. Thus, the study of crystal geometry helps us to understand the behaviors of solids in their mechanical, metallurgical, electrical, magnetic, and optical properties. The solids are classified crystalline or non-crystalline. First one, we have to see about the crystalline. In this crystalline, atoms are arranged in some regular repetition patterns. Classification classified crystalline or non-crystalline. Some are regular repetitions patterns, classified as monocrystal and microcrystal. Monocrystal consists of only one crystal, whereas polycrystalline have two or many crystals. Non-crystalline are amorphous materials. Atoms are arranged in an irregular fusions. It is not based on a regular repetitions patterns. It is supercooled liquid with very high viscosity. Example, gas, rubber and polymers. Crystallographic items. First, what is meant by crystal? A crystal is a solid whose consist atoms or molecules are arranged in a systematic geometric patterns. Then the definition of a lattice point. Lattice point denotes the position of atoms or molecules in the crystals. Space lattice or crystal lattice. The periodic arrangements of atoms in a crystal is called lattice. Space lattice or crystal lattice. The periodic arrangement of atoms in a crystal is called as lattice. A space lattice is defined as an array of points arranged in regular period. In this diagram, we seen about how the dimensional networks of imaginary lines connecting the atoms called as space lattice. The smallest unit having a full symmetric of the crystal called unit cell. These are all the different types of crystalline systems. 14 possible different networks of lattice points, all crystal based on the possible space lattice. Then crystalline structures. Atoms are positioned in solid in orderly arrangements. Imaginary lines drawn through the center of adjacent atoms form geometric spaces. The first one is BCC, then second one is FCC arrangement, and third one is HCP arrangements. BCC arrangements, the arrangements are shown in figure. Tungsten, vanadium, molybdenum, chromium are the best examples for BCC, that is body centered cubic. Then FCC, face centered cubic. Examples for FCC material: copper, silver, gold, aluminum, nickel, lead, platinum. Then HCP, hexagonal closed pack. Examples: magnesium, zinc, titanium, zirconium, beryllium, canadium. These metals are alloys. These materials are alloys. Alloys are two types: homogeneous and mixture alloys. Homogeneous are subdivided into solid solutions, interalloy planes. Mixers combination of solid spaces. The solids are further classified into two types: substitutional, intersted. What is meant by alloy? A metal alloys are simply an alloy is a mixture of two or more metals or a non-metals. Largest portion is called the base metal. All the other elements present are called alloying elements. The presence of alloying elements changes the physical, chemical and mechanical properties of base metals. The type and extent of change of properties depends on whether the alloying elements are insoluble, dissolve in the base metal, or react with the base metal to form other phases. Based on the structures: first alloy, homogeneous, then mixer. This one already seen. Solid solutions. Solid solutions is the simplest type of alloy. Occurs when we alloy two metals and they are completely soluble in each other. Microscope, only one type of crystal can be seen just like a pure metal when viewed under a microscope. Alloys, solid solution alloys have simpler property to pure metal but with greater strength, but are not as good as electrical conductors. Solid solution is composed of two parts: solute and solvent. The types of solid solution: substitutional solutions. In substitutional solutions are converted into two types: disordered or random or order. Second one is industrial. The cooling curves for substitutional solid solutions for pure metals or compound metals. Time on x-axis and temperature on y-axis. Materials in liquid state, liquid plus solid state, and solid states are shown in figure. When we heating, the metals are in liquid state, and then freezing, it will converted into liquid plus solid. When we cooling the solids or the molten metals, then it's become solids. Then industrial solid solutions. The solid atoms does not displace or solvent items, but rather in either one of the holes or interstick between the solvent atoms. Intermetallic components. Intermetallic components are generally formed when one metals, for example magnesium, has chemical properties which are strongly metallic, and other metals, for example antimony, tin or bismuth, has chemical properties which are only weakly metals. These are all the intermetallic components. There is Mg2Sn, Mg2Bb, Mg3Sb2. Industrial components. Difference between industrial solution, industrial components. Industrial solutions, the solid atoms are not in regular patterns but are randomly distributed throughout the solvent. In industrial component, they are in regular patterns. Then we have to see about the phase diagram. A graph shown the phase or phases present for a given composition as a function of temperature. A plot with the temperature on the vertical scale and the percentage of composition by weight on the horizontal scale is termed as phase diagram. A material in which two or more phases are present. Thank you for watching this video.